Hey Chem30s, it's Manchak here. I know you can't see me, but here's my hand. I'm going to try to help out with some of the questions on LSM 14.2i, which I've had at least one person curious about how to tackle question number one. This what it's asking us to do in this question is it's asking us to change the reference half cell so that we can come up with a new reduction potential for this and this and this. And what that means, okay, just as a refresher, I'm going to put this up underneath here. Remember, our reference half cell is usually this one right here, the hydrogen half cell. So our reference half cell is always set to 0. So this question is asking us if we were to change the reference half cell to a standard mercury 2 half cell, then what would our new reduction potentials be? And so what that basically means, and it's relatively simple once you figure it out, is that here is our mercury 2 half cell, okay, which has a reduction potential of 0.85. What that basically means then is that this is going to become 0. Okay, I'm going to grab a pencil to write that in so I can erase it later on. So essentially this is becoming 0. Okay, so what that means then is that if this becomes 0, everything down below it is negative and everything above it now is positive. And all of these numbers change by the difference between 0.85 and the 0 that we had down here. So that difference is 0.85. So, for example, if we're looking at the chlorine half cell, okay, bringing this back over here, our chlorine half cell is plus 0.36, okay, but now it is 0.85 closer to 0. And so what we would do there is we would take our plus 0.36 and we're going to subtract 0.85. Okay, so on my calculator, okay, we're going to do 1.36 subtract 0.85, and that's going to give us 0.51 volts. Okay, so all we're trying to imagine now is if we go back and we're rewriting this table basically, and so everything here and here has changed by 0.85. So it's not asking about this one, but this half cell right here will now be negative. And how we get to that, because it's got to be below 0 now, because this is our new 0, is we're going to take 0.84 and subtract 0.85 from it. So we now know that this one has become positive 0.51 volts. Okay, and then the next one is asking about the nickel half cell. So the nickel half cell, if we find it on here, is way down here, okay, at negative 0.26. Okay, so even though it was negative, what we're going to end up doing is subtracting even more from it. So it's going to become even more negative than it was before. Okay, so it would become, here's how we would do this. We would take our negative 0.26 volts and we'll subtract our 0.85 from it, and that is going to give us negative 1.11 volts. Okay, so whenever a question asks you to assume we've changed the reference half cell, okay, what I want you to do then is just simply set whatever it's told you to as 0, and then all of these values adjust according to that by the same amount, the difference between where it was before. I guess one last thing to point out then is that in some of these questions it's asking about the cell potential, like for question number 2. Here's the thing, even if we change the reference half cell, which we might do, sorry, it's not that one, it was this one that I was thinking about, part C. Even if we change the reference half cell, what that means though is the difference between these two is still the same no matter where you are on the table. So you could figure out the cell potential for a chlorine nickel cell, either using our standard hydrogen half cell, or you could switch it to here. And try both, and you'll see that what ends up happening is you end up with the same value for both, because the difference on here, they are the same distance apart on here, meaning they're going to have the same cell potential. Okay, I hope that made sense to you guys. I hope this method allowed you to see some of this stuff a little bit live and in real time. And if you have more questions, as always, you can email me. Talk to you soon.